This question is difficult and worth a lot of points, so you definitely need to know how to solve it. Let's look at the question. The problem asks us to compare sizes, specifically to compare these fractions. Look, 8 over 11, 53 over 56, 117 over 120, 28 over 31, and then 2 over 5. Should we find a common denominator? It's not easy at all to find a common denominator, right? There's no pattern, and forcing a common denominator is just too troublesome. But if we look closely, I notice that for each fraction, what's the difference between the denominator and the numerator? They're all different by 3, right? All right, so using this feature, what am I going to do next? I'm going to subtract each fraction from 1 minus each of them, just 1, subtracting each of these fractions. I'll compare the differences I get first. What's the point of doing this? Let's try it out and see. First, 1 minus this fraction gives us 3 over 11. Then 1 minus this one is 3 over 56. And subtracting this one, 3 over 120. Now subtract this one, it's 3 over 31. And this one, it's 3 over 5. Everyone, take a look. We know that when the numerators are the same, the larger the denominator, the smaller the fraction. So if I want to compare their sizes now, let's suppose we arrange them from largest to smallest. Which one of these fractions is the largest? To find the largest fraction, we should look for the one with the smallest denominator, right? So among these, which one has the smallest denominator? The 5 in 3 over 5 is the smallest denominator. And since it has the smallest denominator, this fraction is actually the largest. So look, next, from largest to smallest, it's 3 over 5. Next, it's greater than which one? It's greater than 3 over 11, right? Then it's greater than 3 over 31, greater than 3 over 56, and greater than 3 over 120. Some students might think, oh, I want to simplify the fractions. But don't rush to simplify yet. This problem isn't about that at all, right? So now that we've done this, what's the point? These aren't even the numbers in the question. Let's think about it. What we just did was subtract each fraction from 1. Let me write an equation. Isn't it basically 1 minus a equals b? This b is the number we just compared, right? Because you're subtracting these numbers from 1. All right, when 1 is fixed and doesn't change, look, as b gets bigger, what happens to a? Doesn't a actually get smaller? See, 1 minus a equals b, so as b gets bigger, the corresponding a actually gets smaller. And isn't this a exactly what those numbers represent? So in the process of comparing sizes just now, the largest number, the largest b, actually corresponds to which a? Isn't it 2/5? When it's the largest in the comparison, what should its corresponding a be like? It should be the smallest. It should be the other way around, right? Can everyone understand this? So that's why we need to use 1 minus it to determine it first. Because after you've figured that out, you can then determine the corresponding original expression. So in the original expression, take a look. Its corresponding a is 2/5. It corresponds to 8/11. It corresponds to 28 over 31. It corresponds to 53 over 56. And it corresponds to 117 over 120. The largest one actually corresponds to the smallest, and the smallest one corresponds to the largest. So what symbol should we use to compare the sizes of this sequence of numbers? Look, for this problem, once you compare the sizes, isn't the final answer already clear? All right, we've finished this problem. I suggest everyone give it a like and save it to your favorites to watch a few more times. Otherwise, if you want to use such a useful method again, you might not be able to find it.